So does this model agreement match up with observations? We'll be taking a look at that very shortly. This El Nino has actually been the strongest El Nino ever on record for Nino 3.4, this region of the tropical Pacific, and Nino 4, this region of the tropical Pacific. It is going to be known as the strongest event west of 120 West, while 1997 will be known as the strongest event east of 120 West. And there is a very critical distinction there, which I'll be getting to momentarily. First, we can see that in October, the warmest sea surface temperature anomalies were further east, right between 80 West and about 120 West. That has expanded further to the west as this Nino has become more basin-wide. You can see very positive anomalies stretching all the way to 170 West, while as Nino 1 plus 2 has actually seen cooling compared to early October, which may indicate that the sea surface temperature analog model could be correct in its depiction of this becoming more of a west-based El Nino by the time February rolls around. So this is the crucial bit I noted earlier. So warmer winters from east-based events tend to occur as a result of the best upward motion setting up further east, which tends to set the Aleutian low further east, which floods the country with Pacific air. Likewise, colder winters happen from west-based events, and that's a direct result from the best upward motion being further west, keeping the Aleutian low further west, not flooding the country with Pacific air. So this is taking a look at outgoing long-wave radiation, and you can see that anywhere where you see reds indicates a reduction in outgoing long-wave radiation. And this is significant because clouds actually reduce the amount of heat going to space. So we can actually tell where the clouds are just by looking at this map. And clouds correspond to areas of upward motion. So this map is actually another good indicator of where the best upward motion is setting up. So this is the warm composite. You can see the best upward motion is centered between 120 West and 160 West. But notice with the cold winter composite, you can see that it is centered further west. There's actually no huge upward motion occurring near 120 West, and it has a very, very evident kind of tail north of the equator, right around 10 to 15 north or so. You can see that the best upward motion center between 160 West and 180. So how does that compare to this year? You can see that there is actually a very remarkable similarity between the cold El Nino upward motion years and this year. You can see that it is centered right around the same exact location as the cold El Nino years. You can also see the tail kind of protruding out here, which is also present in this particular 30-day average outgoing long-wave radiation anomaly. The blues and purples and pinks represent areas of reduced outgoing long-wave radiation, which corresponds to increased cloudiness and increased precipitation, and also reflects as to where the best upward motion is. You can see that we have that continuing in the most recent update, right again near the date line between 150 West and 180 West. You can see there is no upward motion occurring near 120 West, which is completely the opposite what you would expect with a warmer, more east-based forcing, one we saw in 1982, 1983, and 1997, 1998. You can see that there is also a difference with 850 hectopascal zonal wind anomalies, with the warmer years to the left and the colder years to the right. Notice with the colder years, the best 850 millibar anomalies are actually west of the east-based years once again. And what this map shows is this shows 850 millibar wind anomalies. So anywhere where you see greens, yellows, or reds, that indicates winds that are coming from the west. So it's heading in a positive X direction. So that's why we assign it a positive value here. Anywhere where you see negative values, that indicates winds that are coming from the east, going in the negative X direction. So that's why we assign negative X values to easterly winds. And El Nino, by definition, is slowing of the easterly component to the trade winds in the tropical Pacific, which is why we would expect these 850 millibar winds to show up during El Nino years. What's really interesting, though, is that this year is actually a hybrid between those two. You can see there is areas of wind to the west of the dateline, but there's also areas of wind to the right around the dateline to the east. So this is actually kind of a hybrid between warm and cold years, and that could be an indicator that this year will end up somewhere in between the warmer and colder years, at least according to this indicator. So what's really interesting is that this year is warmer in the West Tropical Pacific compared to the East Tropical Pacific compared to 1997 and 1982. So anywhere where you see yellows, greens, or reds, that indicates regions that are warmer in 2015 than in 1997 and in 1982. Anywhere where you see colder blue, purple colors, that indicates regions that are colder in 2015 than they were in 1997 and 1982. So they are colder here in 2015, warmer here in 2015. So this indicates that the best upward motion should be centered further west than what it was like in 1982, 1983, and 1997, 1998. So I also did a comparison between 1986, 2002, 2009. It's more uniformly distributed here. 2015 is warmer than these years on a more uniform scale. So this is better, but it's not exactly ideal. This also is not ideal, but this is the best I could find. This is actually the anomaly differential between 1957, 1972, and 2015. You can see that, once again, anywhere where you see greens and yellows and oranges indicates regions in the tropical Pacific where 2015 is warmer than 1957 and 1952, the composite of those 2 years. So you can see it is warmer, but it is not as warm as the other composite I showed you here before. And so that indicates that the distribution of temperature anomalies is similar to these 2 years. And even though this year in particular had a very cold northern Pacific and should not be a top analog, it should be considered as to the distribution of tropical Pacific temperature anomalies, since it does look like this will at least be central based, if not west based, toward the latter part of the winter. What's really interesting is we can also take a look at the Aleutian low placement during October and see where that led to the winter weather pattern later on. So during the warm years on the left, you can see that the Aleutian low is actually very far east into the West Canada and into Alaska, while the cold years had it very far west, right southwest of the Aleutians, resulting in that Alaskan ridge and the continental U.S. trough. Looking at this year, however, you can see that it is actually not exactly like either of those 2 years. It doesn't have the trough into the west coast like right here, and it doesn't have it as far back as in the cold years, but notice that it is a little bit further east in the cold years and a little further west than the warm years. And the best composite that matches up where the Aleutian low placement was like during October is 1957 and 1986. It also matches up very well with the warm Alaska and warm Northwest Canada, as well as the positive North Atlantic oscillation, which led to the kind of semi-mild, near average October for both of these composites. So now taking a look at the quasi-biennial oscillation, it is roughly a 13-month oscillation that deals with winds in the tropical stratosphere, and whether it is coming from the east, it is a negative QBO, or is coming from the west, it's a positive QBO. You can see this is the normal index right here, but we also have the derivative of the QBO on the right here. So you can see that it is a 13-month oscillation, so it is roughly a fairly predictable oscillation, and therefore, since the DQBO DT values are once again approaching 0, this could be an indication that this is getting ready to peak and it could fall off by the time the winter season rolls around. And this is particularly crucial because if it falls to neutral, that could have an implication for another oscillation, which I'll be getting to shortly. The North Atlantic oscillation will be influenced if the QBO starts off at a positive state and then crashes down to a neutral state. That would favor a negative North Atlantic oscillation with blocking activity near Greenland and colder temperatures into the east. Here is a table from Al Marinero. You can see that the negative NAO is favored when the QBO is falling down into the neutral areas. It actually starts off positive, which if it starts falling, the NAO might initially be positive before it goes down into negative territory, which also would support a backloaded winter, more wintry weather in the second half of the season. So this is semi-interesting. I didn't really put too much stock into this, but this is a correlation analysis between the North Pacific sea level pressure and the resulting North Atlantic oscillation state. So if it's below 1013, it would support a negative NAO for December through March. So it saw a North Pacific sea level pressure just above 1010 millibars. So that would support the mean December-March negative NAO. So this is also another similar indicator. If the October 700 millibar zonal wind is less than 8.5 meters per second, as it was this year at plus 3.47 meters per second, that would also support a negative NAO. There is no real causation to this. It is just a correlation analysis, so caution should be taken when using these indices, but it will be interesting to see if they did indeed correctly predict the state of the NAO this winter. Another oscillation we need to take a look at is the Arctic oscillation. Very similar to the NAO, except it deals with the Arctic basin. Higher pressure results in cold air going southward, negative AO. Lower pressure in the Arctic basin is indicative of a positive AO and keeps cold air by the pole. So that is relevant to the Snow Advance Index, and that deals with the rate of change of snow cover across Eurasia during the month of October. And according to Dr. Judah Cohen of Atmospheric Environmental Research, the Snow Advance Index was a standard deviation above normal, so that would support development of a negative AO starting in January. And we are already starting to see evidence that the polar vortex is starting to become perturbed in December. However, there is a lag between the polar vortex perturbation and the resulting change in the Arctic oscillation. So December should probably average in the positive AO range, but the negative AO will probably kick in once January rolls around. So now what's really interesting, this is another correlation analysis done by WSI. The top 10 most negative AO years in July support a negative AO, all had a negative Arctic oscillation with the following winter. So this could also be a mere coincidence, but it is an interesting coincidence nonetheless, especially because 2015 saw the second strongest negative Arctic oscillation on record for July, placing it right about here if the correlation is valid. However, this seems very extreme, as 2009-2010 had extreme levels of blocking, and it is questionable as to the degree of blocking we will experience this year, this time around. Solar variability is right around moderate levels right now, and there are studies that show that positive QBO and high solar activity actually support a negative AO, negative NAO. But since solar activity is not overly strong and only near moderate levels, I don't think it would have much of a factor for this winter's weather, since it is not really favoring any direction right now. So the Pacific Decadal Oscillation is an oceanic index. The positive index can be seen with the horseshoe of warm water here. The negative index can be seen with the horseshoe of cooler than normal water in the North Pacific. The top 5 strongest positive PDO winters of +1 or higher are shown above. You can see that not only does the Aleutian low signature pop up, but the West Canadian Ridge as well, and the resulting Southeast U.S. trough. And since 2015 is expected to have a strongly positive PDO during the winter, this is very interesting for the prospects of the upcoming winter. The Atlantic multidecadal oscillation is expected to not really be much of a factor, since it is expected to remain near neutral levels, and as a result have no real clear indicator as to where it will swing in terms of what it will favor for the upcoming winter pattern. I will be having a third video dealing with the analogs and which analogs got weighted most in the upcoming video. Thank you for listening.